Imagine you're a scientist, and you are so confident in your work that you predict the exact year a volcano is going to erupt. You literally circle a date on the calendar, you get all your gear ready, and then crickets. The volcano is a no-show. Today, we're going to dig into why this one missed appointment has so many scientists so incredibly worried.
All right, let's get right into it. So back in 2015, this volcano, axial seamount, erupted pretty much right on schedule. Based on all that amazing data, scientists made a super confident forecast. The next one would be this year. But, well, here we are. The volcano is just quiet. I mean, the ground is swelling up, the little quakes are happening, but the main event? It's missing in action.
And that really is the central mystery here, isn't it? It's not just that the prediction was a little bit off. It's that all the warning signs are blinking bright red. The volcano seems totally primed to go, but for some reason, it's holding back. And that suspense is what's making the people who study this thing for a living very, very nervous. To really get why, you need to meet the main character of our story, axial seamount. It's this massive underwater volcano sitting about 300 miles off the coast of Oregon. And listen, this is not just any old volcano. It is a one-of-a-kind deep-sea science lab. And when I say deep sea, I really mean it. Axial's peak is almost a full mile below the surface of the ocean. I mean, down there, the pressure is just crushing, and the environment is one of the most extreme places on our entire planet. You'd think it's the perfect place for a volcano to hide its secrets, or so you'd think. That's because scientists, through this huge project called the Ocean Observatories Initiative, have basically turned this spot into the most monitored piece of ocean floor on Earth. They have laid out hundreds of miles of this bright yellow fiber optic cable to power a whole network of instruments that are tracking this volcano's every single move. The level of precision we're talking about here is just astounding. Get this. These sensors are so sensitive they can actually feel the moon. So when the moon's gravity pulls on the ocean and the tide rises, that tiny extra weight of the water presses down on the volcano, and the instruments actually pick up the tiny earthquakes it causes. I mean, that is the level of detail we are working with here. And just think about the engineering challenge to install all this. Imagine trying to plug in an extension cord in a pitch-black room, except you're doing it a mile underwater with a robot arm in pressure that's strong enough to turn a truck into a pancake. It was an absolutely astonishing feat of engineering. And all that crazy effort, it totally paid off in 2015. Scientists were right there, with all their instruments recording when Axial last erupted. It gave them what they thought was the perfect blueprint for what to expect next time. They caught the whole show live. They literally watched the seafloor swell up like a balloon as magma filled it from below. They counted thousands upon thousands of tiny earthquakes as the pressure was building. Then, boom, huge cracks ripped open, lava poured out, and the whole crater floor just dropped about 8 feet, like a broken elevator. So here's the crucial point. This wasn't just a bunch of random data. It was a clear, repeatable pattern. The scientists finally had their baseline. They knew exactly what the signals looked like right before an eruption. So when those same signals started up again, the ground swelling, the quakes climbing, they made their forecast for this year with a ton of confidence. Which, of course, brings us right back to today. The signals hit the exact same levels they did back in 2015, all the alarm bells were ringing, but the eruption just stalled out. So what went wrong? Well, scientists have kind of narrowed it down to 3 main suspects. You know, this analogy from one of the researchers just perfectly captures the problem. They've watched the pressure build and build right to the exact point where it should have ruptured, but somehow the system is holding itself together. The big question is, why? Okay, so this breaks down the 3 main possibilities. First up, maybe it's just a simple tempo change. The magma pump is just filling the chamber a little more slowly this time around. The second theory, the rock that's capping the volcano could just be stronger, holding back the pressure more effectively than it did before. Or there's a third kind of sneaky option, that there are these tiny hidden fractures that are acting like slow leaks, venting just enough pressure to keep the volcano from blowing its top. Now, this delay isn't just some academic puzzle. No, it has very real-world consequences. The longer this volcano waits, the more nervous scientists get. And believe me, it is not for the reason you might think. First things first, let's be clear, this is a super deep ocean event, and the water above it absorbs nearly all the energy, so there is absolutely no tsunami risk here. No, the real danger is to that priceless scientific equipment.
The lab is literally sitting inside the test tube. Those expensive yellow cables and super delicate sensors, they're right in the splash zone. And here is the real kicker. The volcano is now officially overcharged. It has already swollen past the point where it popped back in 2015. What that means is it has way more magma stored up, so when it finally does go, the eruption could be much, much larger. A bigger blast could rip open brand new cracks in the seafloor, sending lava flowing in directions they can't predict, and it could totally wipe out millions of dollars of equipment in a matter of seconds.
And the real worry, it isn't just about the money. You see, axial seamount was supposed to be the gold standard. It was the easy one for testing these prediction models. It's calm, it erupts on a pretty regular schedule, and it is wired up with every sensor you can possibly imagine. And that is the huge existential question that is haunting volcanologists. If their models fail on the most predictable, most heavily monitored volcano on Earth, what does that say about their ability to forecast the truly dangerous volcanoes on land, the ones that threaten millions of people? So as we all wait, the cameras are still pointed at the seafloor, ready to stream the whole thing live whenever it happens. The question is, when that stream finally starts, are we going to be watching the validation of a scientific model, or are we going to be watching the final broadcast from a multi-million-dollar camera as it gets swallowed by a river of molten glass?